We started this question last lesson, and I asked you guys to finish it off at home and promised that I would finish it off with you before we start today's content. So that is where I'm going to get started today. Okay. And also ask, of course, my co-host, guys, how could I forget? Gamo also is the co-host. Okay. So what was step one again? What was step one for the sum? We've already done it. That's what we did last lesson. Okay, that will be the gradient. Okay, it's a coefficient on a linear graph is the same as gradient. I will highlight it for you just now and show you where it is. Okay. Why are so many people's screen blank? I don't know. I hope it's not everyone who can't see my screen because that would be very worrying. Okay. All right. That's fine. Should I stop sharing and share again, maybe? Or, okay, there we go. There are some steps. If those don't work, then let me know, guys, and I will stop sharing and reshare, and hopefully that shall work. Okay, so what was the first step? We had to put this in standard form. So let's remind ourselves, standard form means that we want this y to be on its own. So we have to get rid of everything around the y. So we started off by taking 3x, taking it over, and negative 9x, and taking it over. Okay, so then we're going to be left with 4y equals 2x minus 9, which were already there. When 3x goes over, tell me, guys, what does it become? If it was positive, then 3x becomes, let's remind each other. Yes, Oratile. There we go. Yes, Oratile.
Hi, ma'am.
Hello.
Ma'am, can I please ask a question, ma'am?
Okay.
So, ma'am, let's say, ma'am, we're finding the gradient and, ma'am, the y-intercept and x-intercept, ma'am. Ma'am, let's say the x-intercept, ma'am, becomes maybe either a decimal or fraction, ma'am. How do you plot it, ma'am?
You plot it according to where it is. Look here. Let's say the x-intercept is like a half, right?
Yes, ma'am.
Between 0 and 1, you know that a half is exactly in the middle.
Oh.
So you plot it there.
Okay, ma'am.
So these numbers are just guidelines. Some teachers don't even put numbers on their Cartesian plane. And then, you know, 9/10 are going to be very close to 1. So you plot it very close to there. Okay.
Yes, ma'am. Thank you, ma'am.
You're welcome. Okay, guys, I see you guys in the chat telling me the answer. It will become negative 3x, and then obviously negative 9 becomes positive 9. Now let's add our like terms. 4y equals, what is 2x minus 3x? What's 2x minus 3x? We should already have this in our books. I see the people that are writing notes. Checking our book from last lesson. There we go. Okay, almost. What's 2x minus 3x? Negative 1x. Thank you very much, Dumishan. Negative x. We don't have to write the 1. Okay, negative 1x. And then positive 9 minus 9 gives you what? Positive 9 minus 9, 0. So the 9s are gone, right? Now we have to divide by 4 to get rid of it. So let's do that. Divided by 4, divided by 4. Therefore, y equals negative 1 over 4x. You guys said there was a 1 there, right? Now let us substitute to find the points that we are going to be plotting. Let's substitute. Is anyone who did this at home? I wonder. Okay, first one, substituting the first x, that will be negative 1 over 4 times negative 2, which is equal to, a negative and a negative give you what? Mass is going to be Two negatives. What do I get if I'm multiplying two negatives? Positive. Beautiful. It's going to be positive. 2 times 1 is 2 over 4, which is the same as a half. Now I'm substituting negative 1. Negative 1. Again, a negative and a negative gives you positive. 1 times 1 is 1 over 4. Now I'm substituting a 0. Anything times 0 is how much? Anything times 0 gives you what? 0. So we don't even have to go through all of that. It's going to be 0 over here. And now I'm going to 1. It's going to be negative a quarter times 1. Anything times 1 is just that thing itself. So this will be negative a quarter. And finally, I'm substituting my 2. Negative 1 over 4 times 2. It's going to be negative 2 over 4, which is negative a half. If you feel like I'm going a bit too fast, that's because we did this already in the previous lesson. If you are lost, please go watch again how we do this in that lesson, okay? So then my points are a half, quarter, 0, negative a half, a quarter, and negative a half. There we go. Now let's plot this. Let's plot this, okay? And this goes back to the question I just answered from Muratile. First one says, negative 2, which is over there, goes with a half. So a half is halfway between 0 and 1. So it's somewhere there. That's point number 1. Negative 1, there we go, goes with a quarter. So that's even lower. That's like there, right? 0 goes with 0. Oh, I forgot to take. There we go. Green is a little bit off there. And then we plot again. I'm going to use blue again. 1 goes with negative a quarter, which is about there. And 2 goes with negative a half, which is about there. Now let's draw a line, which I now don't have to struggle with. Drawing my line. Oh, why is it red? I forgot my stuff was red. Never mind. So anyone who plotted this graph, and does your graph look the same way as this one? I hope someone did this. Let's fix our graph. Obviously, you guys will have a ruler, and that is my graph, which is y equals negative a quarter x. Are we good? Do we understand? If you're here for the first time, you might be a little bit lost, but we did this extensively in the last lesson. But everyone else, I'm checking in. Are we good? If you're here for the first time, do you sort of understand what happened? Thumbs up, thumbs down, see if thumbs up. Yes, it is a linear graph. Okay, we're beautiful. Even Katie's like, yes, I'm good. Wonderful. So last week we were given equations and we were expected to plot the graph. This week we're going the other way around. So this time I'm giving you a graph and I'm asking you for an equation. So this is graph number 1. Okay, this is graph number 1. Now, my general form of an equation that we will be using is, we've spoken about this when we spoke about the gradient. Y equals mx plus c. Okay, so usually we have to find the value of m. Remind me again in the chat, what is m? What do we call it? Is the what of the graph? It's okay, welcome, Tiamo. Yes, Oratile. Yes, Oratile.
M is the gradient of the graph, ma'am.
Thank you very much. This is the gradient of the graph. I hope we remember and we revised how to work out the gradient. So that will be the gradient of the graph. And we can work out C in 2 ways. Who remembers what the 2 ways to work out C is? Let's see, Umpile. Yes, Umpile.
It's intercept.
Which intercept? It's a specific one.
It's a it's a y intercept.
Yes, Umpile, you are fabulous. Oh, intercept. So we can work out C in two ways. The one way is it's the y-intercept. And the second way, thank you, Tsebang, we can work it out through substitution. Okay. Sometimes a graph doesn't show the intercept. So then you would have to substitute points and find it. Okay, guys. Now, sorry, my little table setup here is not working, so I was fixing it. Now let's work it out. We need points on this graph that we can use. Tell me some few points on the graph, guys. We only need 2 points. Give me some coordinates that you see on the specific graph. Let's see if we remember how to write coordinates. Diseto says how. I'm assuming you say substitution. You means about substitution, and I will show you just now, Diseto. I need you guys now to give me 2 points that we're going to use. Eddie says 4, 2, no. Fencer says 6. And guys, remember we're starting with the X and then the Y. It feels like we're forgetting. Yes, Kanyo, first point, -1 and 2. What other points do we see here? 3 and 6, 3 and 6, beautiful. Point number 2 there, 3, 6. What else? 2 and 4. 2, 4. Beautiful, guys. Okay, so I'm going to choose 2 random ones to use over here. Okay. So the 2 points that I'm going to use from the ones that we have so nicely chosen are 3, 6, and 2, 4. So using the points 3, 6, and 2, 4. Now, remind me, how do I work out the gradient? Oh, let's see if we remember. I'm going to name this point A and this point B. How do we work out the gradient again? Oh, this was -2. Thanks, Tando, for pointing that out. That was a -2, not a 2. Who remembers how we work out the gradient? There we go. Okay, I'm going to remind us once, and I'm hoping we remember from now on. Remember, the gradient is the y at B minus the y at A divided by the x at B minus the x at A. Tell me, guys, does it matter which order I have written these in? Does it matter? No, but if I've started with B in the numerator, check here, I have started with the coordinate B, then I have to start with B in the denominator. Okay, Malibongwe, raise your hand. Let's talk about it. No personal chats in the chat. Oh, that sounds so weird. There we go. Hi, Malibongwe.
Ma'am, how is M equal to YB minus YA divided by XB minus XA?
It's the formula for a gradient. Do you have a different formula?
No.
Were you here when we were working at the gradient?
Yeah. But I was just lost, ma'am.
Yeah, so you take the y coordinate of one coordinate and you subtract the y coordinates of the other one. So if we do that, it's going to be, what's the y coordinate for B? Hello? Malibongwe, are you there? Nope, never mind. Okay, guys, let's help. Thank you. That would be 4. That's the y coordinate for B. Minus, what is the y coordinate for A? Six divided by, what is the x coordinate for B? Thank you. 2 minus the x coordinate for A, 3. Okay, equals. Now we just simplify. What's 4 minus 6? I'll take your hand just now, Malibongo. 4 minus 6. What's 4 minus 6, beautiful people? It's not 2. Thank you. Negative 2 over 2 minus 3 is negative 1. Now we're dividing a negative and a negative. 2 negatives give you what? What do 2 negatives give us? Let's do this. A positive, and 2 divided by 1 is 2. That is our gradient. Now we want C, right? Someone said C is the same as the y-intercept. Someone said C is the same as the y-intercept. Yes, Tando?
Hello, ma'am.
Hello.
Ma'am, I just wanted to find out does the order matter when we do this? Because when I wrote down the question, I started with A and then B.
It doesn't matter, Tando, but you must start with A on both of them. So did you start with y of A and x of A?
Yes, ma'am, I did.
Great, and you got the same answer.
But ma'am, here I got a different answer.
What's your answer?
3.
Maybe we didn't add properly. Okay, what's y of A?
Y of A is 4, ma'am.
Look again.
Oh, it's 2, ma'am. No, it's
Here's A. What's the y coordinate for A?
it's 6, ma'am.
There we go. Is that the mistake you made? That might be the mistake you made. And then the y of B?
It's 4, ma'am.
There we go. And at the bottom, the x of A,
It's 3.
x of B.
2.
Does your sum look like this one that I just wrote over here?
I got for 6 minus 4. For 6 minus 4, I got 2. And then 3 minus 2, I got 1. And then when I divide, oh,
I love it. I love it. Relevations, guys. Relevations. So you see, it doesn't matter, Tando.
yes, ma'am.
As long as you start with the same one at the top and at the bottom. Okay.
Okay, ma'am. Yes, ma'am.
There we go. Wonderful. Okay, so what is the y-intercept in this case, guys? What is the y-intercept? This is very easy because this graph hasn't moved. What is my y-intercept? Where does the graph cut the y-axis? Let's not guess, guys. Look carefully. Where does the graph cut this axis? Let me highlight it nicely. Yep. Thank you very much to everyone who say 0. So if my y-intercept is 0, that means C is 0, isn't it? That means C is 0. Now we substitute. Therefore, my equation is y is equal to, instead of m, I'm going to put the gradients that we found. So I'm going to say y equals 2x plus 0, which you don't have to write. So that means y equals 2x. And someone asked me about a coefficient. This is what we're talking about. It's your gradient. It's the m. In this case, c is 0. So we don't have to write it down. Okay, guys. So that's my equation. So this graph has an equation of y equals 2x. You know, I always say you must test your answers. Is our answer correct? If I input -1, do I get an answer of -2? Let's see. So y equals 2 times -1, which is -2. That means my equation is correct. Beautiful. Guys, do we understand? Thumbs up, thumbs down. I just realized someone asked me, how do you work it out with substitution? I just realized you can, and we haven't done it. But do you guys understand? There we go. Let's say we didn't want to use the intercept. I'm going to do it on the side here. Let me do it on the side. So after we find our gradient, we're going to have y equals 2x plus c. So then you use a random points that you can find, okay? Let's use 3 and 6. So 3 and 6, between 3 and 6, which one is the x, which one is the y? Which one is my x? Which one is the y? X is, what's x, guys? We're working with 3 and 6. I'm showing you how to find it using coordinates. Okay, x is 3. That means wherever I see x, I'm going to put 3. What's y? Thank you, Disetso. Y is 6. That means I'm going to put a 6 wherever I see a y. Now, let's substitute. That means it's going to be 6 equals 2 times 3 plus c. So 6 is equal to, what's 2 times 3, people? 2 times 3, 6 again, plus c. Now, if I want c to be on its own here, I'm going to have to move the 6 over. When it goes over, it becomes what? If it was positive, then it's going to become, thank you very much, Kamahelo. 6 minus 6 equals c. Therefore, c is 0. So we got the same answer, guys. So whoever asked about how do we work out with substitution, now I forgot who you are, I'm very sorry. Do you understand how we can find c in both methods? Actually, does everyone understand the two methods of finding c from the graph? Do we all get it? Yes, I see thumbs up in the reactions. Thank you. Wonderful. So depending on your graph or whatever you're comfortable with, you can either look at your y-intercept, or you can substitute a point and find c using equations. Okay, let's do another example. I think we're doing well here. We're doing well. Okay. Let's see. Okay. Which first one is the problem, my dear? Please try to screenshot so that we can move on quicker. Try and take a screenshot. If you can't, then we're gonna upload this video, okay? And you'll be able to to watch it and pause it and everything you need, okay, Sarole? Okay, I'm hoping you have taken a screenshot. And I'm opening podcast. I don't know what's going on. Here we go. Okay, we have one more graph we can do here before we move on. There. Now, First things first, coordinates. Let's find some coordinates. Send some coordinates in the chat for me. Let's see. What have we here? Send me some coordinates. 0 and 7. 7 is not on the graph. Okay, well, yeah, 7 is not on the graph. 3 and -3. Beautiful. Found out point number 1. 3, -3. Wait, 3 and negative what? Yes, 3. Why did I confuse myself for a second? 1 and 3. 1 and 3. That would be correct. Where did you see 9? 5 and 1. No. 0 and 2. No. It's 2 and 0. Guys, we are forgetting how we write coordinates. Remember, you write the X first and then the Y. So if it's over there, then it's -2 for the X. And let's say 4 for the Y, then the point will be over there. Okay, if we don't remember this, we need to go watch the first videos of graphs. Most of us were still on holiday when we started this, and that's okay. Okay. Okay, 4 and -6. Beautiful. It's another point. 4 and -6. Okay, 3 goes with -3, guys. Wonderful, we have 3 points. So, again, our equation is y is mx plus c. Now, let's work out our m. Let's start with m. Start with m. I'm going to name these points D and E. So my gradient is equal to the y at D minus the y at E divided by the x at D minus the x at E. Once again, order doesn't matter as long as they're in the same order at the top and at the bottom. You guys will forgive me for color. I really like color. I think it helps us to see stuff properly. So y of D minus the y at E. What's the y at D? What's the y at D? There we go. Thanks, Charlie. The y at D is 3. Thanks, Mobile and Kanyasile. Minus, what's the y at E? Thank you, Gamachelo. -3 over. What's the x at D? Yes, Gamachelo. The x at D is 1. Thanks, Charlie and Tando. Minus the x at E. There we go. 3. Now, I know someone might be confused, so I'm going to just show you quickly before we move on. The negative in the sum is this one over here, okay? But we also have a -3. That negative comes from the coordinate. That's why we end up with a negative. Tell me, guys, what do 2 negatives give us? If you have a negative, what do you get? Thank you. So this turns into a +3. So then 3 plus 3 is 6 divided by what's 1 minus 3? 1 minus 3. -2. Not just 2, guys. Now we are dividing a positive and a negative number. So my answer is going to be what? I love this participation. Like everyone is just here for it and sending messages and like answering. I love it. I am here for it. There we go. -3. So we have our M. Now we have to find C. What's C just looking at the graph? What is C? Just looking at the graph. Kamogelo, focus. Just looking at our graph. Remember, C is your y-intercept. Y-intercept. Where does the graph cut the y-axis, not the x-axis? This is the y-axis, the one that goes up, down. There we go, Eddie. I'm concerned about people saying 2, guys. This is the y-axis. The blue one is your x-axis. Now we want the y-intercept. Where does my graph cut my y-intercept? It's over here. Do we see that? And that is how much? 6. So by just looking at the graph, we know that C is 6. If that doesn't work for you, let's work it out. Let's do a calculation, okay? So we got a gradient is -3. So it's y is equal to -3x. Okay, I hate writing on these lines because they're very difficult to see through. So let me go to the side here. So for those of you who can identify it from the graph, that's beautiful. If you can't, let's substitute. Y equals -3x plus c. Okay, that's what we got. We got that x is -3. Now I'm going to use a random point. I'm going to use 1 and 3 and substitute them. So remember, 1 is the x and 3 is my y. Okay. So it's going to be 3 is equal to -3 times 1 plus c. What's -3 times 1? It's -3 times 1. I'll answer you just now, Zianda. We need to finish this calculation. Thank you, guys. Plus c, -3 goes over. It becomes a -3 goes over, and it becomes a +3 equals c. Therefore, c equals 6. So my equation is y equals -3x plus 6. Okay, Zianda asked, how is it 6? How do we know that from the graph? Zianda, what is the y-intercept? We need to remind ourselves of all the lessons that we've had, okay? A y-intercept is where the graph cuts the y-axis. Now I've shown you there which one the y-axis is. It's the yellow one. Watch this one that I'm highlighting in yellow now. This one. That's the y-intercept, okay? Now the graph cuts or intersects with the axis at 6, Zianda. Do you see that? 1, 2, 3, 4, 5, 6 there at the top. That's why we are using 6. There it is over there. I hope I've answered your question, Zianda. You're welcome. Okay, thumbs up, thumbs down on finding equations using graphs. Are we good? Thumbs up. Even a heart. You guys are so cute. Everyone else, there's about 77 of you guys. I need more responses than 9 ones. Come on now. Okay, there we go. Wonderful. Now, I think we deserve a brain break. What do you guys think? I'm glad. Khotatso. We deserve a brain break. Okay, hands up. Let's hear. Brain break. Hands up. Oratile's hand went ba. Oratile.
Ma'am.
Here's your question, Oratile. Would you rather live without a microwave or without a kettle?
Without a kettle, ma'am.
Well, how are you gonna boil water?
Ma'am, ma'am, I can boil them with the pot, ma'am.
Do you know how long that takes?
And then it's fine, ma'am. Because ma'am, I remember I don't even drink cheese, so ma'am, it's fine.
What about, guys, load shedding? Have you never had to boil water to take a bath? I see you guys.
See, ma'am. Because ma'am, Fruity, ma'am, there's even gas stoves, ma'am. It's quicker than an electric stove, ma'am. So I just can't.
Okay, Oratile, thank you very much. Eddie, are we ready?
Yes, ma'am.
Rhymes. Eddie, are you ready? Here's
Yes.
Eddie's question. Would you rather own a restaurant or a clothing store?
I would rather own the restaurant, ma'am, because if you choose the clothing store, you would need people to make sure the clothes isn't stolen and stuff. And the restaurant, everyone has to be sitting and eating. You can't be like standing and eating because it's awkward, ma'am.
Okay, Eddie. Look at your peers choosing clothing store. I can't believe this. Guy, Kamachalo, your business is gonna go out of business. Kamachalo's restaurant to get free food. No, that's not how it works. You're losing business. Come on. Restaurant. People who are saying clothing store. I must be hungry. Malibongwe, are you ready? Oh, someone I never thought of that.
Yes, ma'am.
Someone just brought up something so nice. There are too many rules for a restaurant. Your meat has to be at a certain temperature. You have to clean a certain way. Oh, hectic. Here's your question, Malibongwe. Would you rather lose your sense of taste or sense of smell?
Yo, ma'am, my sense of smell. Because
you'd rather
I want
taste.
to taste my food, ma'am.
You guys like food? Oh my goodness. You guys love food. I can't believe it.
Ma'am,
Not a
I love
single
myself
person
way
taste.
too much to starve myself.
So no, you can still eat, but you won't be able to taste it. Like you'll be eating just to be alive. Jay.
But still, food is not the same without the taste.
This is true. But imagine if
Mhm.
you can't smell yourself when you're like not smelling right. Eee. You're just walking around and you have no idea that something is not right.
Yeah.
Imagine, guys. He said so. He said so. Are you there?
Yes.
There we go.
Yes,
Here's
ma'am.
the question. Would you rather go to any restaurant for free forever or any theme park for free forever? Listen to these people who like food. Where would you rather go?
I prefer a restaurant.
I knew it. Me, I knew it. For free forever. Where would you go specifically? Do you have a favorite restaurant?
Yeah, my favorite restaurants are Nando's. I have plenty of them.
You like food in J. You must just say.
Yeah, I must just eat.
Oh my goodness. I can't believe this. You guys love food. I just knew this was gonna go that way. Bridget is being slick and saying there's food at the theme park, so I can go in for free. I see you, Bridget. I see you. I never thought of that. So you'll just say, no, but I'm going to the restaurant. I'm just going to the restaurant. That's all I'm doing. And then you get it for free. Smart. Love it. Okay, guys, we have one more section to do. Today is quiz day. So let us do some special graphs. Let's do some special graphs, okay? So these all have to do with gradient. I don't think we're gonna have enough time to find the equations of the graphs, but it's okay. This will be graph A, and this will be graph B. Now let's work out the gradients of graph A and graph B. Okay. There's a point on A that would be -1 and 5. And another point is there, which will be -3 and -1. On B, we have a point there, 1 and 3, and 0 and 0. Okay, let's work out the gradients. Let's get started. Let's get started. Has anyone worked out the gradient of A or B? Now we are working, guys. Should I write down the equation of gradient for you guys? But it depends on what you name your points, okay? So remember, M is equal to the y at point A. Okay, now I have to name these points something else. Excuse me. Jeez, that was hectic. E, F, G, and H. So the y at F minus the y at E, it doesn't matter if it's the other way around, over the x at F minus the x of E. And you do the same with B. Does anyone have an answer? Anybody have an answer? I hope the silence means we're working. Does anyone want to do this with me? Hey, hi, Gudlano.
Hey, ma'am. I'd
Hello.
like to try.
Okay, let's go for it.
Yes, ma'am.
What do I write?
You're gonna say -1 minus 5,
-1 minus 5.
and then for x, it's gonna be -3 minus -1.
There we go.
And your sorry, ma'am.
It's okay. What's
Zero.
-1 minus 5?
Ma'am, is it 4?
Try again. You add -1, you're moving back 5 times.
Okay.
There we go. Tando has helped you in the chat.
Oh, -6. Okay, thank you, ma'am.
There we go.
And then
And now
you're gonna
check this.
it's gonna give you a positive, so you're gonna say -3 plus 1, which will give you -6 over -2.
Beautiful. What's -6 divided by -2?
3.
There we go, Kuplana. Thank you very much.
You're welcome,
Let's
ma'am.
find someone else to do the gradient of the other line with me. Lelita. Lelita, are you there? Hello. Okay, I'm gonna do this one then. Before we go to a quiz. Okay, so the gradient for B, I should write B over here.
No.
There we go. Hi, Lelita.
Hello. Hello, miss.
Hello. Okay, I think Lelita's having some connection issues. That's okay. Okay, the y of G minus the y of H over the x of G minus the x of H. which will be, my chat box is in front of my point, so I can't see. Y of g is 3 minus 0. X of g is 1 minus 0, which is 3 over 1, which is 3. Oh, what's going on here? What have we here? Staying to the chat. Guys, if we don't listen to the rules, we're going to kick you into the waiting room. Okay? We are sticking to the lesson. Now, what do we notice about the gradients? They are both 3. So these are special lines, guys. What are parallel lines? Do we know what parallel lines are? Do you remember what parallel lines are? That's the next section, so it makes sense to end off with this. What are parallel lines? Dumishang, I'll answer you just now. I saw your question, acknowledged. Oh, we all forgot. Lines that will never touch. So if you look at these two graphs, guys, does it look like they're going to touch? They're not going closer and closer to one another. They are the same distance apart from one another. Okay, so graphs that don't touch always have the same gradient. Okay, guys, they always have the same gradient. So if they tell you, work out the equation of a graph that is parallel to another one. So if I say to you, work out the equation of a graph that is parallel to y equals, nope, of course I'm going to use 3 again. Y equals 5x plus 2. What's the equation of the graph that you are working out? I mean the gradient, excuse me, the gradient. What will the gradient be of the graph that you are working out? If I'm telling you this new graph is parallel to y equals 5x plus 2, then the new graph will have what type of gradient, guys? What will the gradient be? 5. Thank you, Zianda. Okay.